Hi everyone, I miss you guys. I hope you're all doing well. So I thought that we would start to work on a peer review, and that just talks about, for us, one little thing with limits that we actually put off. So we're going to talk about L'Hopital's rule. So what happens is sometimes when you evaluate these limits, so if we put in pi into h of x all over pi minus pi, you'll notice that we will get sine of 2 pi over 0, which is 0 over 0. So that's what happened if we would actually plug this in. We would get 0 over 0. But that doesn't mean that the limit doesn't exist. What that actually means is that we start to use something called L'Hopital. So L'Hopital is a rule. Here's the dude. He figured out that essentially if you have this limit as x approaches some value c of f of x over g of x, and f of c equals 0, g of c equals 0, but g prime of c does not equal 0, then what you can actually do is rewrite this as f prime of c, so the same limit x going to the number, f prime of x over g prime of x. So this is L'Hopital's rule, the hospital. Is sometimes what people like to call it. I like to be all French and everything and write it L'Hopital. So if you get 0 over 0 or infinity over infinity, then you can take the derivative of both the numerator and denominator. Cannot spell denominator, and redo the limit. So if we take a look at what that was before, originally we had lim, it's h approaching, so x approaching pi, sine of pi plus x over pi minus x. If we actually take that limit, we will see that instead we have x minus, this is so bad, oh my god, limit x approaching pi, sine turns into cosine, pi plus x stays the same, all over, this will become a -1. So now if we plug in pi, like we're normally used to, pi is just a number, we'll have cosine of 2 pi all over -1. Cosine of 2 pi, so if we're here, here's 0, here's pi, go back, now we're at 2 pi, so that's 1 over -1, which should have been -1.